Hello everyone. This is the first video of the series on complex numbers. In this video, I would like to talk about the number system, which may help to understand existence of the complex numbers. In human history, long time ago, humans started to count 1, 2, and so on. Much later on, the existence of zero discovered later on the history. All these numbers, 0, 1, 2, are called the natural numbers. Later on in the history, we realized that this equation x plus a is equal to 0 does not have any solution in the natural numbers. And the idea was add the solution of such equations into the set and create a new numbers. Like x plus a is equal to 0. If a is equal to 2, for example, then you have minus 2. Then you can add to the integers. All these numbers are called minus 2, from minus infinity to the minus 1, 0, 1 to the plus infinity gives you the integers, the set of integers. And it's denoted by z, and this is denoted by n. Later on, and people realized ax is equal to b does not have a solution in integers if a and b do not have common divisors. So if they are not divisible each other with some number, then this equation does not have a solution in the integers. So the idea was that let's add the solutions into the set, extend the set, and give a new name. So we have the rational numbers. We arrived at rational numbers that way. So minus 1 over 2 will be added because that's a solution of an equation like that. Or all these numbers, rational numbers are of the form integer divided by integer. These are all rational numbers. Of course, including the integers and including natural numbers. And then of course, there are some other equations which cannot be solved in rational numbers, like x to the n is equal to a. If n is a positive number or negative number, a is a positive number. This cannot be solved in the rational numbers. So adding these solutions to this number, extending the rational numbers, and also some interesting numbers as well, like transcendental numbers, exponential numbers, and pies, and continual fractions. We add all of those and we obtained real numbers. So the equations that I'm talking about here has a large number of the equations type. So from rational numbers to the real numbers, it takes a lot of intermediate fields between them. From real numbers, and consider the equation x squared plus 1 is equal to 0. This equation is not solvable in the real numbers because that is the solution is square root of minus 1. If we add the square root of minus 1 into the real numbers, then we obtain a kind of a vector space, right? Real numbers plus I times the real numbers. So this is a definition of the complex number. Again, the same idea, we obtain these numbers by adding the solutions of this equation to the real numbers. Only one equation will give us. From here to here, there are many equations to add, infinitely many. But from here to here, we have only one equation to add. So we can view the complex number as a vector space over the real numbers with bases like 1 and I. So every complex number can be written in this format. Real number plus another real number times I. That's a definition of a complex numbers. And the next videos, we will try to work on those numbers, calculus, and we are going to do some geometry and linear algebra with it. Thank you for watching.